Okay, okay. Okay, there we go. I'm late, but I'm not late according to the delay that I put. I'm actually early. So, like, am I really late if you think about it? Um, what's up, what's up, what's up? Let's see, let me check. Sometimes, my youngest will come in here and mess with the mic. The gain does look suspiciously low, but I'm looking at my OBS and it looks fine. Let me know if the audio. I think I'm gonna turn the gain up a hair and just try not to go crazy with it. Okay. Yeah, that's looking a little better. I just need to keep it like steady and we should be fine. Um, yeah, we'll start. If Hassan's here, we'll start with this. Right? Hassan is the one that asked for this. Let me look. Um, yeah. Yeah. So just let me know if you're here. If you're here, I'll cover the paper. If not, I'll wait a second to cover the paper. Um, hold on. Let me make sure. I think I have someone in the chat. If you could confirm that the stream is healthy, that would be great. Last time I talked for like 10 minutes to no audio without realizing it, which is never ideal. I'm pretty sure I got it right now, though. Like, I'm pretty sure. Ooh, I don't think I have desktop audio, though, right? Someone confirm this for me. Where should I go to try to get desktop audio? I don't know. We'll cross up. Well, the problem is sometimes we just come up on some like audio video paper, and then like we play the demo, and then there's that would be a bummer. Let me see. Would real-time interactive world models have audio? Maybe. But why did I click view PDF? Project page. Do we have audio? Let's see. Can you hear that? I don't think you can hear that, right? What about now? You can hear it, but it's too loud, maybe. It looks like it's maxing out at something crazy on my end. Because this should sound normal, this video. Like, I know you can't see it, but I'm just checking audio-wise. I can hear some music and it doesn't sound okay, very loud. Let me see how to fix that. Sorry. Um, how the heck? Can I just manually fix it like this? I guess I'll just take... Or wait, okay, two ways to try to fix it. Okay, way number one. I'm just gonna... Okay, first off, I'll show you the video, so you're not like, just like, what the heck is he doing? There. Or better yet, like this, okay. So, is this better? If this fixes it, that's great. If this doesn't fix it, there's one other thing I want to try. Let me know though. 43 seconds. It's still very loud, covers my voice? Okay, sorry. Alright. How about now? That's decent, no? Maybe like there? What you think? Way better? Okay, perfect. I feel bad because I've never touched this setting in my life, which means every time I've ever done audio before, I've just been like torturing everybody, but nobody said anything. It's kind of a vibe. I should just leave this on in the background now. I've been wanting to find music that's like not too obtrusive, but it'll have to be for later. And I know when I mentioned it in the Discord, some people were like, "Oh no, definitely don't grab music or whatever. That would suck." So that's part of why I'm reluctant to do it. Anyway, speaking of Discord, let me share the stream to the Going Live channel real quick. Bam. Okay, sweet. Okay, how's everyone doing? How's it going? Geo4, Michelle, how's it going? Kimalik? 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 Kima. Oh, there's so many ways I can think of to pronounce it. They're probably all wrong. But there's lots of ways. And again, Hassan, if you've arrived, I'm ready to go over the paper that you asked for. You can just let me know at any time. Also, let me check Discord. I got a DM from someone Uh, their Discord name is Weewa, and that's the name I think I'll use right now. I got a message from Weewa. I told them I'd answer on stream. If you're here, I'll answer it now. What's up, a duck? A strong duck? A duck that's strong? Strong duck? Not meant to be pronounced. You're good. Okay, cool. So I'll just treat it like gibberish that I get to say however I want. Um, I'll say it's something that sounds kind of like what I read, though. Okay, so someone posted this on Discord since the last stream, I think. Papers with Code Revival. Um, it does look, it reminds me of every attempted social media archive page I've ever seen, right? Where, except instead of needing people to participate to have upvotes, it's just pulling stars from GitHub, which is a neat idea. It's not immediately reminding me very much of like what I enjoyed on Papers with Code. But let's see. Like if I click it, I guess it is strictly tied to the code, right? But I like Papers with Code because it had leaderboards. So I'm curious, like image classification, browse state of the art. Is there like a leaderboard here? Because that'd be pretty sick. Will it ever load? I have good signal, right? Like this isn't like my internet didn't just drop. It's this website now. Let's check. Yeah, it's the website. It's totally the website. Come on. Okay, let's try this one. What's happening? Did it even make a request? 401. Huh. Am I supposed to be signed in? Have any of you tried to use this site? Does it just not work? Well, that's a bummer. That's the part that I was like, that'd be pretty sweet. Whoa. This is kind of neat. But nothing works. Am I okay, this did load. Okay, that's cool. Huh. Wow. So you can just kind of scroll things that get cited a lot. Interesting. So it's got like methods, which is kind of cool. If this worked, it'd be pretty cool. It's broken, so it's not very cool. Oh, do you have to, like, do they auto index or is this, there's no way that this is a bunch of people submitting themselves, right? It's so many. Maybe, I don't know. So it's like Hugging Face Daily Papers or like the old Papers of Code, you submit, like you put the thing there and then conferences. Oh, are they auto pulling themselves from conferences? Because it seems like they have a decent chunk of these. I wonder. Oh, wait. No, they don't. Like, they have all papers, but then categorized, this does not seem like it's summing to 2K. Or maybe it is. I mean, I guess we can look through and see. Yeah, like some of them don't have a category, right? That's funny. Did I review this paper? I might have reviewed this one. Hang on, let me look. Let me look on my other tab. Did I review that? Sorry, a lot of these diffusion caching papers have the exact same name. Not the exact same, but it's like there's one called Tcache, there's one called Mean Cache, and I've reviewed reviewed at least SpecCA, which is spectral aware caching. So I probably haven't reviewed this. It's not quite. It seems like it's just an interpolation on things that I have reviewed in terms of the title. Yeah, I didn't review it. I wish I reviewed it. Some of the papers I reviewed for that CVPR were a little weaker. I reviewed this one though. That recently popped off and went super viral relative to AI on like LinkedIn. The Sakana people posted it and it got like 100 or sorry, like 1,000 likes or something like that. So I was very, I don't know if I was proud, but I was like, hey, if I didn't vote, accept on that paper, it probably gets rejected. Because I think before rebuttal, I was the only accept, I think. So if I don't vote accept, maybe they don't rebut. But anyway, I think it's a neat paper. It's very confusing though. Complicated method. All right, let's try to get some papers to go through. And Weewa, tell me if you're here. I'm seeing more people. Weewa, if you're here, I will answer the questions you DM'd me. If not, I'll answer them before the end of the stream and just you can watch the VOD, I guess. Okay, so this is daily. We want weekly. And okay, Minecraft right in the top of my thing. Let's look at that. We might open that thing I just closed later. Same with this thing, we might open it again. Okay, so executive strategy for self-evolving agent skills. Sure. Dynamic variance adaptive, advantage optimization. No. Well, maybe. Okay, locate anything. Okay, yeah, sure. Let's vision language grounding with parallel box decoding. I mean, lots of bounding boxes really fast with language grounding. I don't know. We'll see. A lightweight and scalable alignment framework for rethinking cross-layer information routing. Sure. Yeah, let's do that. Lens, rethinking training efficiency for T2I models. Yeah, I'd be curious. That should touch some scaling law junk. I wonder what it does. Qwen VLA. Oh, I was seeing this. Someone posted this on some channel I was on. Yeah, let's look at that. Why not? W bench. Comprehensive multi-term benchmark. Okay, yeah, benchmarks for world model. ProRL, effective reinforcement learning, agent explorative, a model for generative UI, pipeline aware and expert calibrated benchmark for professional cinematic video generation from Tencent. Yeah, let's look at that. Foundation protocol, a coordination layer for agentic society. Yeah. From pixels to words. Okay. Yeah. Spatial Bench is your spatial foundation model an all-round player. Omni Retrieval, Mobile Gym, SciAtlas, self-improving language models. Sure. Is this like NAS? Collecting 50 effects in one LoRa? No. Try Splat. Wow, we never see Gaussian splatting up here, do we? We got one from Zhejiang. Should we look at that? Maybe? I'll try. We just had this open. We can look closer. That's fine. Audio is also kind of a unicorn. Fast and high resolution latent decoding with pixel diffusion. I want to see that. Oh, yeah, some replacement to V8. Definitely want to see that. Research math, scaling research level mathematics via agents, bootstrapping reasoning models to discover. Wow, I cannot speak right now. Jesus. How far is video generation from world model? Okay, yeah, some kind of position paper. Toward native multimodal modeling, a roadmap from Tencent. Selective mixed precision for long context FP4 attention. That could be interesting, but I don't know. Geometry aware representation denoising for robust multi-view 3D reconstruction. No thanks. Personalized then store. Why far looks up. Probing spatial represent. Fine. Generative supervision helps embodied intelligence. Yeah, I should look at that even though the title's like extremely boring. Long AV compass, learn from weakness. Dynamic safety monitoring for diffusion LLMs. What the hell? Wait, no, that's gonna, I mean, fine. It's gonna be like something we looked at something yesterday in the surprise makeup stream. I bet it's gonna be like the exact same kind of thing. And something we saw a week ago too, where it's just like you can make predictions and threshold based off the intermediate states, like before the diffusion model's finally predicted. In this case, to not finish the denoising. You can detect that it's going to be unsafe early, I guess. Clean latent predictions. This sounds like JIT. Let's look at it. Share more, search less. Auto research AI, sure. We can look at that. Okay, let's native audio visual alignment. I mean, the alignment's the tricky part. I wonder what that is. Lava Vision, Lava 1 Vision 2. Okay, okay. Geez, we're opening a lot. There's a lot in this like 20 upvote range. Let's see what we can get to. We never get to all of them. Although I kind of have some energy right now, and I'm feeling like getting through a lot of these. So we'll see what happens. Um, let's look at this world model. Okay. Oh, I lost my clock. Dang. Clock, right there. So, okay, I'm on the lower right. We're good to go. Generative multi-agent world modeling between two players. They propose Gamma World, a novel generative multi-agent world model from virtual games to real-world environments. How? How do they do that? So, especially I'm curious about multi-agent, right? So, lots of different agent inputs. Synchronized observations actions for multiple agents as input. Tokenizes each agent stream with shared visual and action coders. Generates future multi-agent rollouts with the causal multi-agent DIT. Where's the DIT? Where's the DIT? Right. Oh, geez. Okay. Where? I see the FFN. We have this fancy rope in there. So we have a sparse hub self-attention followed by the FFN. These are the blocks of this multi-agent DIT. So it's like every agent's actions and observations get tokenized, and then 4D rope within this DIT to get rollouts per agent, right? Every agent needs its own rollout that exists in the same world. This looks like a very fancy rope to exist in the 4D. Because that's the tricky part, is like how do they handle the agent? I wonder if I can really quickly see, like, does the agent just have like an identity, which is like that agent's index? Can we tell from just looking at this? Not clear to me. Because yeah, we have XYT relative to that agent's view, and then the last dimension is it says right here TP. This is P is the agent identity, right? TPHW. And then sparse hub attention. Hub. What the heck is hub? So we have every agent. So yeah, because we have to have this crazy like mask on the fourth dimension. So I guess every agent sees itself only, except for hub. Hub is the only time they see each other. What is hub? I would like to know more about this hub. I'm looking for another diagram. I'd like to learn about it from a diagram. If I can, it's fine though. We'll search text real quick, and then we'll go to a different paper. Hub tokens aggregate information across agents and broadcast it back. So they're just learnable tokens. Wait, can I see where they're like just learnable tokens within every... I guess they're just learnable tokens within this matrix, and they get cross-agent communication essentially. Yeah, they like it gets it from 1, and it broadcasts it 2, 2, and 2, 3, and 2p, whatever. Okay, cool. Is there like an interesting demo with this? I would hope. Sort of. I'm a little confused. Like, where are the... Oh, is this... Okay. Oh, so it's pairs. We're looking at pairs, right? Like, they're in the same world. No. Who's in the same world? Am I crazy? None of these are looking to me like they're multi-agent at all. I'm not gonna stare at this Minecraft thing forever. I'm just a little confused, but it's okay. I'll stay confused and we'll move on to something else. Okay. Executive strategy. I want to understand this self-evolving agent skills, like what they mean by that. Maybe they mean something super obvious, but we'll see. Agent skills today are handcrafted, generated one-shot, or evolve loosely. I mean, that seems really like a crazy generalization to make, but okay. We argue that the skill should instead be trained as the external state of a frozen agent. Skill opt is the first systematic controllable text-based optimizer for agent skills. An optimizer model turns scored rollouts into bounded add, delete, replace edits on a single skill document, and it is only accepted when improves validation. Skilled opt improves whatever. Okay, so we get a text document and we optimize it. Right? And it's like we propose edits. If they improve performance, we keep them. If not, we reject them. So this is like a genetic algorithm, basically. Right? The optimizer model turns trajectories into skill edits. First separates failures from successes. This matters because single trajectories produce failure mini batches, each reflection. Local proposals merge hierarchically. Yeah, this sounds... I don't know. Okay. I don't know. Sometimes the skills are like one of the only things I intend to read and kind of control. But maybe I would want this. Or maybe, I mean, I don't know. If you get a good set of skills to optimize on, or like a good set of not skills, a good set of tasks to calibrate on, then maybe this is fine, I guess. Sometimes though, I feel like part of the point of the skills is like, the model has tons of these benchmark tasks that it was specifically trained for, but my task is just like a little different. And if I put that in a skills MD, the model can handle it. And so it's like, if I already have these well-scoped tasks, is there not better things I could be doing with that rather than like trying to just have a slightly better skills MD? Okay. Dynamic variance adaptive advantage optimization for multi-reward reinforcement learning. I don't know enough about RL, but using multiple rewards is hard, right? That's like going to be the point here. Standard paradigm, models with blah, blah, blah. Efficient value model free alternative to proximal policy optimization. Real world. Okay, so yeah, we'll just take their word for it. I guess I don't see a lot of multi-reward stuff, so I assume it's hard. Reward combination advantage combination suffer from drawbacks. Reward combination frequently generates advantages with excessively large squared magnitudes that lead to training instability. I mean, that's easy, you just rescale it, right? Advantage combination relies on static hyperparameters, ignores cross-objective correlations. Sure. Dynamic variance adaptive advantage optimization dynamically adjusts the combination weights based on the empirical reward variance of each objective within a rollout group, effectively upweighting objectives with stronger learning signal while suppressing noisy ones. Wait, is this like from rollout to rollout, or is this globally? The corresponding policy optimization objective, blah, blah, blah. This is not keeping my interest long enough for me to figure out the question I just asked. Does it seem to work? Like a lot? A little bit? Some of these benchmarks are pretty saturated, I guess. Right? But is this... This seems to be working sometimes. I mean, so it's worse than GRPO here. It's better, 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 better. Worse, 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 worse. Am I insane? Is it? Did I just do something crazy? I'm super confused. What? Notably, okay. Oh, is it like we're more format compliant? Is that the thing that like we don't run out of length? So we still solve the task, but we run out of the length budget way less than GRPO? GRPO gets too long, is that the main argument? How's GRPO getting great accuracy if it exceeds the length constraint? Huh? Is it just saying you have to repeat, and so GRPO is going to take longer because it's violating the length constraint a lot of the time? Anyone that knows these tasks really well, I've never seen anyone emphasize the length constraint at all. So that's why this is kind of catching me like totally off guard. Um, I guess it's good to have it not be as long. Although this is like not a way that sells me on it very much. Because it's like if this makes me do a retry, then just show me like maybe a time measurement. How long does it take with DVAO versus GRPO? Um, Whereas if it's about like a token number, show me the number of tokens. Just the amount of times it satisfies the length constraint is confusing me a little bit. Hello, Jay. How's it going? We're just going through some papers today. Hassan asked for one, but we're waiting for him. And then someone named Wiwa messaged me in Discord asking some questions. I'm waiting until they say they're here, and I will answer their questions. Okay, let's look at locate anything. Yeah, I'm curious about this. It's like, is object detection back? People are still doing this? Okay, so locate anything supports diverse localization tasks under a unified vision language model. Textual digit decoding spells coordinates digit by digit, and quantized coordinate decoding predicts coordinate tokens sequentially. Parallel box decoding predicts each geometric unit in a single forward pass. What do you mean each geometric unit? Like, so textual digit decoding would do like box, coordinate, and but they do, whoa, like they have tokens to predict like the entire integer at once as opposed to each like, okay. So they support the quantized decoding, but then they're saying that these are like chunks that come out in parallel? Cool. I mean, that's like more of a low level thing, but cool, I guess. And then, yeah, I don't know if I need to look more than that. That's neat that they parallelize it. Okay. Not like the craziest thing, but cool. Okay, rethinking cross-layer information routing and diffusion transformers. I want to go straight to a diagram and see what this means. Cross-layer. Proposed diffusion adaptive routing and previous methods. Whoa, and previous methods. So standard residuals look like this. Yep. Unit like skip looks like that. Yep. I'm on same page as them. Oh my goodness, that font size is psychotic. Okay, block. So one block, two blocks. So we can conceptualize this apparently just in terms of looking at two blocks, which is cool. I think what I meant to see is that I have this skip stream that goes through the whole model, and I have this alpha, which I don't know if this is expressed totally correctly because I'm assuming it's not actually we perform this alpha operator on whatever the input is. I'm assuming it's like addition. That would be a guess. Exponential q of t times k over the square root of d. Okay, actually I'm still a bit confused. Oh no, they explain q is some static w times v sub l. Okay. Wait. I'm after the MLP though. Where exactly are K and V coming from? I'm a little confused. But luckily we have the math right here. Drawing on the recently proposed attention. Okay. Wow, that's quick. Attention residuals, which replaces fixed residual accumulation with softmax attention over depth. Oh, so that's what this is. It's just attention residuals for diffusion. Oh. Let V equal some function on Hin state time step. Denote the output of the ith sublayer. With v sub 0 equals h sub 0 the input embedding, in contrast to the standard residual routing that accumulates these sources into single running stream with unit weights, the proposed DR replaces the unweighted sum with softmax weighted aggregation. Oh, so we really are interesting. So it's like we take everything up to the okay. So It's basically the current layer over the sum of everything before the current layer. And at the start, it's the hidden state. After that, it's some, actually, I'm still a little confused by what's meant here. A little confused. But it says it says the output of the ith sublayer. Oh, okay, so this is just the output of the layer, but it can't quite be the output of the, no, it's, oh, these are sublayers, like attention's a sublayer, MLP's a sublayer. Got it. Okay, so it's just the output of the sublayer. Okay, so V is the output here. Q is a processing of that. Where does K come from then? RMS norm of V. Okay, cool. So we have the output of the sublayer times the RMS norm of that same thing. No. Q is not just the output. Okay, Q is that modulate. So we modulate the output, we take the RMS norm of the output, we multiply them together, we rescale by D. And we're actually doing a softmax of that relative to the sum of all of the same operation over all the prior layers, which is not as expensive to compute as it looks because it's just a sum. We can, like, every time we compute this, we save it. And then we can, like, continue updating the sum as we go. Right? I think so. Okay, so what does this do, like, for the performance? This is indeed quick, insane research pace. Yeah, Samsung, I agree. Pace can be pretty quick. I don't remember enough about the attention residuals implementation to know how much of this is new. I'm tempted to look and see. I wish that this paper spelled it out for me more. Several design choices tailored to the diffusion setting. Like what? What's tailored to the diffusion setting? Oh. Do we have this W, a layer-specific learnable vector that does the modulation, and a layer-specific projection is a sharp departure from the LLM side observation and attention res where the dynamic variant improves only marginally over the static one. Okay, but they're saying that, so apparently the LLM for this Q, okay, so the K is always going to be the RMS norm on V. And then in the LLM, they would just use W itself as Q. But they're saying that instead of having K be the RMS norm of the sublayer output, and then Q be this static weight, learnable weight per layer, you should multiply the W by the V, not the RMS norm V, but just V itself. So it's like you modulate it. So you see that? I guess it makes, so attention residuals found that works better too, but not by a lot, whereas they say that it looks better by a lot. Oh, and I guess they're saying the difference between static and dynamic is how T enters the per layer query. Oh, because it's like, when it's static, unless you want to learn a bajillion of them, they have to be time independent. But then when you do the dynamic, it's not time independent. That makes sense. That's very satisfying. Okay, so let's look at performance now so I don't just like tunnel on this paper forever. Without guidance, with guidance. Sorry, I'm looking for, we're looking all at standard residuals. DIT, SIT, SIT plus, some UNet stuff, and then their method. Okay, I'm seeing a lot of bold down by their method. It's not lying bold though, right? People lie with bold lately. It's crazy. Okay, they do way less itters. That's something I noticed right off the bat. Are they going to try to sell that to me, or is that like, does this take a really long time? And so like the fact that they use a lot of itters or less itters is just, thank God they use less itters because the convergence is slow. Another concern I have though, even if they can say we get similar convergence using less itters, this is the danger of these ImageNet experiments. It's like when I want to use this for text to image, I'm not training on the same million images 200, 1,400 times or whatever. I'm training on images once. And I actually need to be able to get through my training budget in finite time. And so I don't care if you can be half the iterations. I need all the iterations so that I can see all the data. And so I'm already scared, wondering how slow this is going to be. And also wondering if it justifies how much it increases the parameter count and therefore the memory pressure of the model. So I guess I'm worried about a lot of the ways that this might work. But I'm interested, I'm intrigued. Let's see what they try to say about it. Okay, so ablation time step awareness. Okay, so static versus dynamic versus static trying to put the T in. I mean, yeah, the dynamic is just way better. Although it gets pretty close to static with T injection the longer they go, right? That's a bit of a gap. In fact, it's even better eventually. So that is freaky. Maybe static with T injection. What do they say about that? Is static with T injection just better? Okay, time step awareness is the key ingredient. So maybe still don't do dynamic. Once you train enough, it's just not needed. Maybe. They look at compatibility with repo. Theirs does better. Good for them. Um, Orthogonal to repo even. Cool. So you can use it with repo. Although I don't feel like we're using repo at all in TTI. I feel like it's a CTI gimmick. Maybe that makes me crazy and stupid. I hope not. If it is, tell me so I can fix my life and get all these hidden gains from putting a vision encoder into my diffusion training, when I'm actually doing text to image. Sorry, I'm still looking for like where they're going to say, hey, look at how few training steps we need. Okay, they do say faster convergence, faster convergence. Compared to vanilla, train for iterations, achieve substantially better FID, training only for 6. Yeah, but you're slower. You're definitely slower. I'm looking at the operations you do. You're slower. I just need to know by how much. Um, you can't say 2 times the training budget. You're definitely slower per step. Yeah, I don't know. I might have my auto research implement this guy this week and see what it does in like a TTI setup, and then I'll tell y'all if it's how slow it is. Like for example, do you remember the manifold hyperconnection? I plugged that into my DAT, and because they're kind of hand wavy about how slow it is in the paper. They say that it's slow at first, and then they accelerate it towards only 7% slower. Without doing those tricks, like just vanilla PyTorch, it's 40% slower, so it's pretty bad. But obviously, like you need to do those optimizations, and like maybe eventually I'll get to them, right? So I'm curious about this one. Anyway, uh, is my work Slack blowing up? Hang on, let me check something. Uh, okay, I might need to do something real quick, but it's a quick thing. Uh, give me 1 second. I'm gonna put my work laptop in front of me. Hang on. I'll be right back. I'll be right back. I'm kind of back. I'm gonna leave cam off for just a minute. I am just going to spin up quick codecs thing. Hang on. What is this? Let's see. If I get 5 million things and I put them in, does this even make sense? Like, how many things per CSV is that? 262? Okay. One second, one second. Okay, okay. There we go. Sorry, sorry, sorry. I am really back now. Okay. We're back, we're back. Okay, I'm gonna try this papers with code thing again real quick because it's on the monitor. I really want this to work. Oh, it's working now. Cool. The site was just having some issues earlier. Okay, but I don't... We have no benchmarks, at least for 3D. Maybe let's go to text, maybe we're likely to have some benchmarks. We do. We can click them. And, ooh, nice. We're getting the graphs back. Okay, I like this. Do we have what about for like video generation? Do we have benchmarks? No. So is it up to each community maybe to set these up? And some people put in the time and some people haven't? That's how the old papers of code worked too. That's cool. So we really are bringing it back. I mean, I don't know if we'll ever get like all the old things to put their stuff up, although it looks like these were always some of the benchmarks that were more populated on the old papers with code. So it's not shocking to me that there's some of the ones that you can see more on the new papers with code. Someone went ahead and put ImageNet in. I love this. It totally saturates 2021. And then you just have years of like basically no progress relative to the benchmark technically. That's fun. Ooh, do they do the old? Oh no. See, Papers with Code had a nice thing where it would tell you with or without external data, which does matter quite a bit when you're looking at older works for some of these papers. Otherwise, you're sort of not really showing which method is better, but just whose data was better. And that's a totally different thing. Hey Raj, how's it going? Sorry, when did you post that? I had the okay, I got it within a minute. So I have two goals for this stream actually. One goal is to catch chat messages way quicker. And the other goal is not to ramble so much when people ask me questions. I don't have Ask Me Anything in the title. I wonder if that's why no one's asking me anything. I'm gonna add that to the title. I feel like when I have that in the title, people ask me stuff, but otherwise people just don't ask me anything. There, boom, ask me anything. Okay. Rethinking training efficiency for T2I. I wanted to see this. I wanted to see if it's like having the scaling law perspective or not. So, massive computational resource. 3.8B model achieves performance competitive with, sometimes surpassing models with more than 6B parameters while requiring less compute. Oh, here, let's put up a timer. Okay, so data information density per training batch, 800 million image text pairs, captions generated by GPT-4. Wait, why? What? Why would you do that? Approximately 109 words on average, range of semantic supervision, constructing each batch from images with multiple resolutions and diverse aspect ratios. Oh, that's interesting. I can't say what I want to say, but I have thoughts. Conversion speed through careful architectural choices. Semantic VAE, which has better latence and encourages a strong language encoder that accelerates optimization, while having multilingual generalization from English-only trained data. After pre-train, reinforcement learning, and structural word rubrics to suppress artifacts, improve quality. Reasoner module with training-free system prompt search to better align user requests with the model. And distillation-based acceleration. Okay, so they do RL, and then... Oh, I set a freaking... Whatever. I'll fix this next time. I want to go look at... Okay, so we know the size is like 3B, 4B? 4B. 4B model. 800 million image text pairs. Capture with GPT-4.1 for some reason? I don't know why you wouldn't use a better open model. Maybe they did that part forever ago. And we have any resolution pre-train, which probably means we don't have very many pre-train phases, right? Let's look at that. Okay. But this is the data. So pre-train data and then AKRL data. And this is their caption length distribution. Average length is pretty long. And I'm a little confused because they mentioned having this like semantic VAE, but here I'm seeing just Flux2 VAE. What is the actual VAE? Oh, I guess Flux2's VAE is a semantic VAE. Am I dumb? I didn't realize that. Okay, cool. So they use Flux2 VAE. They think that's better. I wanted to see other things. Like, what's the text encoder? Is it like Qwen 3? Oh, they compared a few things. What did they end up using? GPT OSS? I mean, it's a chunky one. Did they even try a Qwen that was that chunky? No. Oh, but 3B active. So it's comparable. Okay. So text prompt goes through GPT-OSS, goes through some linear adapter, into token concatenation, that's fine. MMDIT block, two stream? I don't think that's right. It's a dual stream. That's crazy. Okay, let's see. Training steps, 120K. So they do one epoch, right? Over 800 million. I mean, it depends on the batch size. What's the batch size? Oh god, they pre-train for 400K iterations? 128 GPUs. Oh, so it's just not very... Oh, they do a low resolution pre-train. So they do a 512 pre-train, and then they continue training for another 400K iters, but over mixed resolution. And again, this is like 0 GPUs, basically, relative to the scale they're trying to operate at. It's crazy they did on that few. This pre-train would have taken forever. Constant LR. I don't know why I'm spending so long here. I wanted to see if they do any scaling law, but they don't. They're just like, we have a model, it's pretty small, doesn't use a lot of data, and it's competitive with... They're saying it's competitive with ZImage Turbo. If I can't go onto AA and find them right now in the leaderboard, I'm just calling this nonsense. Like, it's... I don't know. I'm a skeptic. Yeah, call me a skeptic, especially using like, where's Geneval 2? You're putting this paper out in May, whatever year we're in. It's kind of weird. But here, let's be fair to them. Let's go find them on artificial analysis. Image generation, text to image leaderboard. I can find Flux2 Dev Turbo right here. I can find ZImage Turbo. It's somewhere around here. Where are they? It's been a while since I've been on this leaderboard, I guess. I thought I knew exactly where that model was. Has it dropped down to... Okay, down here. ZImage Turbo. Okay. Now, where's this NVIDIA model, huh? You guys seen NVIDIA? I'm not seeing NVIDIA. Granted, it's expensive to be on this leaderboard, but still. Okay. For some reason, Microsoft research papers just not hitting the same. Yeah, Sam, that was kind of... Wait, was that Microsoft, or was Microsoft 2 papers ago? I thought that was NVIDIA. I might have been confusing with the paper before it. Is it Microsoft? Oh, it's Microsoft. Oops. Was there any NVIDIA in it? Was that just a paper ago? Why was I thinking NVIDIA? Okay. No, it was Microsoft. My bad. I'm slandering the wrong group. Oh my God. Let's just double check. Do we see is Microsoft up here somewhere? Maybe Microsoft is here. I was looking for the wrong here. We can look for Microsoft, we can look for Lens. No, they're not. And it's not like Microsoft can't afford to be on that leaderboard, right? Anyway. Show things. Hi, Matt. I cannot make sense of a paper on my own, but I really want to. Maybe I need more theoretical knowledge. What should I do as a beginner? Good question. It depends on what paper. Like, there's 0 papers you can make sense of, or there's a specific paper you can't make sense of. Because there are definitely papers I can't make sense of, and I have a bit of knowledge. But yeah, maybe you need more background. Maybe you just need practice reading papers too. You definitely, starting out, you're not going to read them the way I do, where I just kind of jump around it trying to mine the info I want to mine. Sometimes that bites me in the ass, to be fair. But you can actually read it all the way, like all the words. That should help. If you're not getting it with that, you should be trying to annotate it. Whenever you get stuck on something, hopefully that's a thing with the citation close by, and you can try to like trace it to whatever the core concept is. Or maybe eventually like you hit some things that you hit in the research paper that confuse you will be like brand new in that paper, right? But like when you're going into prior works, and even within that paper, there will also be ideas that like have Wikipedia pages and stuff, or like have YouTube videos about them. So it's like sometimes you hit the wall, it's like, oh, it's in the last paper. I go back one paper. Or sometimes it's like, oh, this is just a concept that I can look up and learn on Google or with ChatGPT or on YouTube or on Wikipedia or something. But yeah, practice. Practice makes perfect. And if you have no background, like if you've never taken even like Intro to ML, then like take some Intro to ML equivalent or like the YouTube equivalent of Intro to ML. So you at least have some knowledge, background, whatever. Okay, sorry, I need to push this code. Never mind. I need to interrogate Codex a little bit. Also, show thing. Your name. So I got questions from someone whose Discord username is Wiwa. Are they here? If they are, I will answer the questions now. If not, I will continue to wait. Also, Hassan, if you're here, I got diffusion blocks. If you're not here soon, I might just cover it at like 10:30, and you can watch the VOD. Let's look at this Qwen VLA. Okay, never mind. I gotta run this thing real quick. Hang on, hang on. Sorry. Humor me. Humor me. I'll be done so fast you won't even know it. Bam. Okay. Qwen VLA. Let's look at this. Man, we're getting to like there's so many, especially now that we've added like a lot of robotic stuff to what we do. We I don't do robotics, but what some people do, it's like just so many more benchmarks to know. Okay, I like how I've been putting this up and it just says back in 3 minutes. Like I'm here right now. Okay. Unifying vision language action modeling across task environment and robot environments. Yeah, generalizing for robots is hard, but they want to see can you have all these decision-making problems solved by a single VLA, and that's Qwen VLA, which extends Qwen's vision language modeling stack from perception, understanding, and reasoning to continuous action trajectory generation through a DIT-based action decoder. Interesting. Oh, okay. So here's the VLM, the Qwen 3.5. I like how they call it a vision language model. I'm pretty sure Qwen 3.5 doesn't have any VLMs, right? They just have their like 3.5 that happens to be VLM as well as an LLM. Anyway, so we're getting actions through an MLP. Does that mean they're skipping the vision language model altogether? And then we get some time step, and then we get some diffusion transformer which predicts clean action. Oh, this is more like this is like a lightweight encoder to get like the latent states for the action. And then okay, this is just to have like the shape of an action for some action tokens. We probably could have had learnable action tokens here, which means I kind of want to understand why it's an MLP here if its only inputs are the noisy action. Let's see if we can find that one tiny detail, maybe? It looks like it's standalone though, for sure. I mean, here they're even like eating the action. Like they're just saying it's like prompt VLM DIT clean action. So yeah, I will just treat it like it's some kind of embedding. What's the objective? We have an action loss and a VL loss. What? Okay. Flow matching action loss. For all samples of continuous control targets, we supervise the action expert the conditional flow matching objective. Okay, so we can compute a flow matching loss over the actions if they're continuous. And then to preserve and strengthen the multimodal capabilities of the backbone, we keep a standard next token prediction loss on auxiliary vision language data, fine-grained embodied action captions, autonomous driving VQA, and general VL pre-training corpora. Oh, so like we have answers and stuff that we can get out of the data that we can then compute that. What? Can I see that somewhere? Because like I'm seeing like, you know, they're surfacing action outputs for me here. Oh, and then this is for an RL stage. So there's a text to action stage, a CPT and SFT stage. But oh, this joint objective is for which stage? I assume stage 1, which is the T2A stage. No, no, it's not. I'm confused. Which stages have which objectives? Someone help. Help. Do I care? Do you care? Do we care? Raj, this is this is a good one on VLA. Momo Act 2, action reasoning models for real world deployment. Okay. Hey, maybe it'll be compared to in here. Okay, lots of pre-training data. Probably actually not a lot of data. The robot manipulation trajectories are expensive. So let's see how much data they actually have. Lots of public, 10,000 hours. And then 1,000 hours proprietary. In-house? Quinn's got a robot lab? How much did that data cost? It's like, oh, I'm trying to remember the cost of robotics data off the top of my head, and I can't remember if what I know is per minute or per hour, which makes a pretty big difference. So I'm just going to keep my stupid mouth shut before I embarrass myself. Okay. Let's copy that from my buddy. All right. So 11,000 hours of trajectories, which is how many trajectories? Because we're not like generating video, so we don't really care about the hours. We care about, okay. Oh, and 8 million, nice. Tell me the hours, tell me the number. 8 million synthetic simulation trajectories. Which contributes a further 3.7% of the mixture. So 8 million, 3.7%. What's 8 times 25? Like 200 million trajectories? That's a lot. That's actually a lot. Cool. Wow. Interesting. Okay, oh wait, 14,000 hours. Yeah, they already told us that. Sorry, I'm scrolling now because I would just want to see results. And I want to see if they compare to this Molmo. That'd be kind of interesting. I don't think they do. Wait, why are we on table 4? Because these were just like introducing tasks and stuff. Okay, that's why we're on table 4. Here, we can go full screen because the fonts are a little tiny. These are specialist models that do better than the generalist models, but right? Just better. They're just better. Yeah, they're just mostly. I mean, good ones are better. Bad ones are worse. Good ones are better, right? Still, it's cool for a generalist model to do pretty okay. Because yeah, these, like they say, the specialist means every benchmark is fine-tuned separately. And the scary part of that is it means you can't really do robotics unless you identify all the different benchmarks. On the other hand, though, like the way that you build data for a generalist model like this is you get 200 million trajectories that cover those different tasks and action types and whatever, right? So it's like you can say, well, they have to fine tune on each of those. It's like, well, you pre-train on all of those. It's kind of more the same than it is different. Raj wants Momo Act 2, so we'll do that real quick for Raj. Anyway, what do y'all think of my assessment? I think it's decent. No, it's like it's not really different to pre-train on all versus to pre-train on none but fine-tune separately on each. I suppose the only way it's different is if the synthesis of all of them is the whole world, right? And then everything's in distribution. Then sure, I buy the argument. How does this happen to me? God hates me. Like, that's insane. Why? No one wants the archive HTML. Nobody wants this. Why do you do this to me? Okay, cool. Yeah, we'll look at this real quick, Raj. Hi, Matt. Hey, Hassan. Oh, hey, we can do diffusion blocks. I hope everybody's ready to suffer, because it is super confusing. Okay. Yes, Matt, I'm Wiwa. Previously asked you if you can kindly give me a roadmap on, as an early researcher, I can more intuitively research and publish. I do have experience in training CV models. Okay, Sam says, I'm interested in knowing how much VLA is generalized to new tasks. And Wiwa says, in medical DLL models. Okay, so a few different things. Okay, so Raj, in a minute, we will do diffusion blocks. Sam's, I am also interested in knowing how much they generalize to actually new tasks. I guess it depends on how you define new, but it seems like the strategy in the paper we just saw is train on all of it up front. Like, do I want to look close enough to see? They did not seem to be withholding any particular sort of thing. But like robotics is such that normally in like regular robotics, yes, I don't do robotics. I kind of do enough robotics to know that a lot of the time your camera moving in the same setup is like out of distribution. So like there is something to be said for training on a lot of control, and then someone else collects new control data and you can do well on that data. That's kind of generalization, even if you have tons and tons of control pre-train examples. Yeah, Hassan, I was waiting until you were here. I was gonna cover it today regardless and just tell you, sorry, watch the VOD. But I was waiting for you to cover it today. Anyway, let's do Wiwa's questions real quick. I'm actually gonna see if Discord is like, I have streamer mode on, but it's not like actually fully anonymized. It says it's supposed to truncate usernames, but it's only truncating some usernames. So let me see. I will copy this into my text file and put that on the main monitor. Okay, let's see. This is what we were asked. Or here. Sorry. To be fair, your username here is that. So I hope it's not too... Okay. So, hi Matt, hope you're doing well. I really appreciate your content. It gave me crucial practical insights on research, but as an early researcher, I have plenty more to know. It would be really helpful if you could kindly answer a few of my questions here on your videos. Roadmap on how I should get better at research and publish. That's a question. Okay. 1. As I want to pursue a PhD, it would be really helpful if you could also get some advice on reaching out to professors. Okay. Formatting CV and explaining things that you feel are necessary. Thank you again for being authentic to your content. I wish you the best. Okay, cool. So, okay. Actually, these are separate things, right? So, reaching out to professors, one thing. Formatting CV, other thing. And then things I feel are necessary. Okay. So, let's stay organized. Okay, cool. So, let's try to answer these. Let's try to be quick, but let's also send my buddy real quick the link to these sharded CSVs. What? Oh, it's 250. Oh, oops. I should edit my message. Okay, cool. So, roadmap on how I should get better at research and publish. Roadmap. How to get better at research and publish. So, I do think that we can simplify this to remove the and. Publishing is like sort of the end state of a lot of your research, right? You get it ready, you do it properly, you can publish it. So it's like, let's talk more about getting better at research, because it's like, sure, maybe there are things you could do to get better at publishing without getting better at research, but that's not advice that I'm interested in giving. So get better at research. That is a longer answer maybe than some of these. Formatting CV, that's a good question. So formatting CV, if you called yourself, I shouldn't have deleted that part. Early researcher. I guess, what does early researcher mean? You want to pursue PhD, so you're saying you're an undergrad, right? If you're an undergrad, your resume should probably not be longer than a page. Um, and it should be very easy to find what you've done in terms of research. So, and it should be easy to find your internships. It should be easy to see what your internships were. It should be easy to see what research you have done, if any. That means, like, if you've published a paper or submitted a paper, that should be there, maybe in a publication section, or maybe like bolded under the experience that you did that with. What doesn't help too much is if you had a research experience, but it just very suspiciously has no poster, no paper, no nothing. Then it's confusing more than it's helpful. So when you do have those research experiences or those internships that did research or whatever, it's nice to know what the artifact was. Paper, patent, poster, something. Other resume formatting things. It can be helpful to have, like if you had a mentor, like like if you did research with some faculty mentor, who was that? If you published a paper, what and where, like what venue, like what's other good details? Internship. Those are things I think we look for. It's like coursework could be like putting your courses there. Like courses can be there to like make it complete, but it's not really needed, especially if you're talking about applying to grad school. The courses are on your transcript. So if someone really wants to know, they can look at that. And ideally, you're demonstrating the skills via research, not via having taken courses. In terms of like actual nitty-gritty format details, am I comfortable putting my CV on? Um, yeah, I think this isn't amazing. It's okay. Education's at the top just real quick, because people generally do want to see where you got your degrees or whatever. I don't put GPA, even though mine are good. I just think it's kind of tacky, but like maybe you put your GPA. I don't know. And I guess I've looked at so many resumes and I've just never really looked at that recruiting and industry, at least not for what I do. Maybe if you're doing like engineering, it's more relevant. I don't know. Then you can see my relevant experience. I mentioned papers sometimes. I made a lot of this a lot shorter to fit it on the one page. I should probably, I haven't updated this with anything I did there, so I guess this is a year out of date, basically. It only has stuff I did during PhD or before PhD. So it'll mention like papers sort of collectively, or paper. Um, this is basically like a failed internship, right? But like not putting it here feels weird. I organized a workshop, so that's here. I organized a workshop at CVPR. Conference reviewer stuff, but that's like something not undergrad. But you can see the gist of it, right? Like very little on education, more focus on experience. It's very short, but that's part of just trying to fit it on one page. And then I do have a page for my publications where I sort them into like what the heck they're about. Anyway. Oh, and I bold my name so you can see where I am in the list. That's how I format mine. Yours would be a bit different because you probably don't have a page for papers, because you're asking me how to get better at papers. Okay, so reaching out to professors. You need to try a lot. Like we had someone come on the stream the other day that's like, I reached out to 80 and I said that's probably not enough. To expect to get replies. I think they got one reply out of 80, and that reply just told them apply like normal. And that'll be a lot of the replies you get, or just like apply through whatever like the mainstream channel is. So like you need to make sure the email is written like it should be genuine. It should come across as you having like done the work to demonstrate some genuine interest, which is hard to do with also emailing a lot of them. It also should like relatively match your like level of experience and what's already in your profile. Like you try not to reach out to people that do something totally different from anything you've ever done, and try not to reach out to like the most famous people ever if you're maybe still starting. You can also try postdocs, you can try PhDs. Other than that, the main advice is to try a lot. If you have some in-person way to talk to them though, like you can take their classes, um, that's better than emailing, obviously. Take their classes, go to their office hours, that's better than an email. But if you need to email, write a good email. Don't make it too long, don't make it too short, try a lot. Mention useful things. Anyway, 1 second, I gotta grab myself a quick snack. I will be right back, then I'll finish this, then I'll do Hassan's paper. So, just a second. Okay, grabbed a snack. So we're not going to get hangry again. And I'm going to try to answer quicker. So, explain things that you feel are necessary. I think these are good basic questions. Um, I think it is important, like, it's important, like, the sooner you can find a mentor that actually exists in your real life, the better. So that's really important. Which makes this important, but also you can reach out to PhD students and you can reach out to postdocs. It's like the best undergrad I ever worked with did not find me by way of my professor, found me by way of another even more junior PhD student in our same lab. So that can be a way to get good traction. How I should get better at research. This is a very open-ended question. Um, it definitely starts with knowing the fundamentals. And, oh, you added some more details. I think you answered the 4 question survey videos, like, do you want a PhD? Ani's interview? Yeah. So for some of these, I point you to Ani's interview. I don't think I've ever answered roadmap on how I should get better at research very effectively, but like the gist of it is find a real in your life mentor. Um, get into the habit of reading papers regularly. And you actually said you have a fourth author at an IEEE local conference. Will that count? It will validate some experience that's on your resume as having been like real in a way. I mean, it also like some people look at those frankly as like not real at all, which is probably kind of mean, but it's reality that they look at it that way. For other people, it is, especially for an undergrad, sort of proof that you participated in something. Uh, Yeah, instead of giving a complicated advice and a lot of roadmap, I'm sorry, instead of giving really, really complicated advice, I would say the roadmap is if you don't know the fundamentals, learn the fundamentals. That means take the basic intro courses or some equivalent online and find an in your real life mentor that can guide you. Um, that's going to be the answer I give today. I think that's a good one. So let's see. Hassan asked me, am I going to Colorado for CVPR? Yes, I will be at the IFM booth on Friday in the morning and in the afternoon. And I'll be around probably random VideoGen workshops, just attending them on Thursday. And then I actually come home on Saturday because I got stuff to do. Okay. Let's look at this, then let's look at diffusion blocks. And let's close the work laptop. I think I handled that. Okay. And let's see. Let's see if this points to Sam's question about generalization. Actually, let's just see what they say. I mean, the whole point of these is that they're generalists, right? I don't think anyone's trying to say that they can really go super out of domain, right? It's more just like we can pre-train on all of them together without like losing performance in any given one, which is sort of the hard part. Like it's hard to train on, you know, one of these benchmarks and not lose your performance on some other one of these benchmarks. These though, these are VLM benchmarks, right? Yeah, these are VLM benchmarks. What about do they not do robotics? Ooh, simulation held out environments. Let's look at that. That might point to some of what Sam's was asking about. Results across Momo space tasks. Okay, so here are the robot tasks. Really simple ones, by the way. Pick and place, open, and close. I know what pick is. I know what pick and place is. I don't know what they mean by open and close. Hydroid. Okay, so here's some robotics results. Why is it so bad at open? It's kind of weird. Evaluation on simulation held out environment. Simulation success rates are evaluated over 1,000 episodes per task. For pick and place, we report both oracle success and success at end. The delta between captures both unstable/unsuitable placement and the inability of policies to determine when a specified task is already completed. Additional report half width. Okay, so sorry, all of these are held out. Or these are just the success rates on the held out environments? Okay, the success rates are pretty abysmal, right? Yeah, they're all pretty low. I mean, I guess they're saying they do better for these held out environments though, but still, I mean, that you would look at success lower than 25% and probably pretty confidently call it failure to generalize, I guess. Oh, how robust is it to out of distribution perturbations? Uh, where's that table? Let's see. Why don't we like link the table? That'd be pretty sick, no? I'm not seeing that part. Ooh, we actually saw this in the paper we just did. I'm kind of curious to pull up the paper and compare across them real quick. History, Quinville. Let's go to Libero. Here we go. Okay, let's just make sure we're looking at the same like subset out of Libero by looking at the pi models. 94.4, 97.6. Somehow it's different. Awesome. It's pretty close though. Probably this is the same basic thing. So like we can look at Quen. 97.9 is worse. Worse. It's worse on this particular benchmark by a tiny, 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 tiny hair. Real world evaluation. This is okay. So this is the 8 real world tasks outside laboratory setting ranging from preparing a pipette, fine tune on the collected evaluation data. Okay, but they fine tuned it on the collected eval data, right? So it's like, sorry, I need to reread the way that they explained the setup for this, which they explain. Fine tune it on 4 tasks from the real world and evaluate each task under 4 distinct outer distribution variants. I'm confused. 4? But then this I thought it said, was it just 4? No, this is like 8. They fine tune it though. This isn't like straight up out of distribution. And is it fine tuned per task or is it fine tuned on all tasks together? Because that makes a big difference too. It's really hard to know exactly what I think about how good this is compared to the other things without like really getting into the nitty gritty on the setup, some of which those details might not even be here. How does this compare though in terms of methodology to the QuenVLA? So with the QuenVLA, it's the diffusion model to use the flow matching to predict our action, right? Whereas here, how are we doing it? We're getting continuous actions using a flow matching objective, using an action expert, which is itself a DIT. So same method at the same time, right? Like is basically, yeah, interesting. Two papers, same method. Maybe this isn't a new thing. Maybe people have been doing DIT for action, which I would know if I did VLA. Is that possible? If I search DIT, can I see if they cite like prior works for using it? Mohammed says, I had no idea you're still live. When are you doing live sessions now? Mohammed, last night I did one to like make up for not having done one last week because my internet was down all weekend. I do them every week, Sunday at 9 a.m., and then I go live randomly at other times. If you want to know when I'm live, I always post it to I post when I go live. Like in the moment I go live, I ping the going live channel on this Discord. I ping everyone that is online. I ping here. So like you'd see it if you had Discord open on your computer or if like you have notifications allowed on your phone. Hey, what's up, Ifta? When you said couldn't join the last stream, you just mean the random one last night? No worries if you couldn't join, it wasn't much. Okay, these are kind of the same paper. I wonder what the difference is in data magnitude though. Whoa. What? That the Quen paper is 200 million trajectories. Is this one 4 million? There's no way. There's no way, right? Is this just like infinitely more data efficient? That's crazy. I mean, granted, like the devil is in the details. You can get a similar number on the benchmark for two things, and it's like, but there might be so many more capabilities in the other model that like it might like when we look at the one benchmark that I know they both report just Libero, they do look the same, but that doesn't mean they're actually the same. And I do just not have the time span. I don't have the patience right now to dig in enough to have the very concrete opinion of who do I think is like being more honest or whatever. Anyway, Raj, can we put paper names that you covered in stream and video description after the stream is published so we can come back to papers? If any of you want to keep track of that for me, that's great. If it's me putting in a little bit more time to this, as cool as that could be, it's not going to happen. Same thing with like other really nice quality of life things like chapters, adding chapters to the VOD after the fact. I'm already like 10,000 years behind on all the videos I want to make. Doing things like chapters or adding the video tiles to the description is just like another barrier that takes time away from the parts of this that I enjoy. But if one of you compiles that, I will happily add it to the official description. That's pretty easy. Set up a Discord bot to remind a few hours before 9 p.m. That could be decent. Or 9 a.m. Wait, you said 9 p.m. You meant 9 a.m. Or maybe you're in a different time zone from me. I could set up a bot that like does not send a notification but sends a message. I don't think I want to notify though unless I'm live. Because I want to condition people. It's like if they see like the ping there, it means like I'm live. Um, okay, let's see. Am I falling behind on what people are saying, or is it time for diffusion blocks? Can we create an animation for this, adding papers and description based on the transcription or something? Um, oh, see, I look at these transcriptions sometimes, and the words it screws up the most are diffusion blocks, blockwise neural network training via diffusion interpretation. You can feel free to keep thinking of easy ways to do it, but until there's a very legitimately easy way to do it, I'm just not doing it. Okay, let's dig into this diffusion blocks, which I actually reviewed. I'm allowed to say that, right? I mean, it's public. You can go see my review, especially since I told you I was one of the more positive reviewers. You can literally read what I wrote. Um, but let's see. Man, I remember this paper being a bit difficult to grasp at the time I reviewed it. So hopefully the fact I've done it before means I can do it again quickly. But basically they want to Okay, so training a model takes a lot of memory. As the model gets bigger, it takes more memory. You need memory to store the forward if you don't want to recompute it, or you at least need memory to materialize the gradients, which you can like greedily recompute the forwards to materialize what you need for the backward, and then not have to keep them in memory, gradient checkpointing, right? To like reduce the memory pressure, but that obviously makes things a lot slower. And there's an upper limit or a lower limit to how much you can even reduce the memory by doing something like gradient checkpointing. There's also things like the model parallel or the sequence parallel that can further help with your memory. But again, there's like a vanishing point to all this stuff. So this paper says we can have a framework where we transform a transformer-based network into independent blocks. And their key insight is that the residual connections naturally correspond to updates in a dynamical system. So with minimal modifications, they convert the updates to those of a denoising process, where each block can be learned independently by leveraging the score matching objective. So it's basically like one way to think about transformer blocks is we have like this stream of information that just goes through. Um, One way to think about what a transformer is doing, which is an interesting way, is that we basically have like a stream of information that flows through the model, right? Starting with like the initial input sequence. And if we ran no forwards, our output would just match the input, right? But instead, what happens is every single block updates the sequence. That's a result of how the residual connection actually works in a typical transformer. Like every block just adds, like it's x plus equals SA, a self-attention, x plus equals feed forward, right? There's no point where we just process x, change x. We're always adding to it. And this addition is actually so let's put it this way. We're always doing x plus equals some layer-wise processing of x, right? But like x is always preserved. This stream just continues just getting updates, which is very, very, very reminiscent of the way that like diffusion denoising works. Where you start with some noise, right? Um, which we can call epsilon. And then this isn't the best way to write this. Epsilon equals this L, I guess let's change it to F. But then we just need like some alphas, right? Pretty similar in many ways. And so they're going to take that sort of insight to turn the transformer blocks themselves into like individual neural networks, basically, that have a score matching objective. So they do the experiments with vision, diffusion, autoregressive, recurrent depth, mask diffusion to demonstrate that diffusion blocks can match the performance of end-to-end training while enabling scaling blockwise training on practical tasks beyond just classification. So this is prettier than I remember it being. But yeah, basically we can take a couple of layers or a couple of blocks, like actual transformer blocks, and group them together to be our diffusion block. Oh, that's the other big insight, if I remember correctly, which is um, every block isn't doing every like all the time steps. Like a diffusion model, if you train like if you consider the block like a single block like a diffusion network, we would need to train it to do any time step. But what they actually do is like input is considered max noise, and as you get to the output, you get to the minimum noise. And so like you're always learning like the same time level, basically, at each block. So you don't have to learn like all the crazy different times. And so like your denoising process is just your feed forward pass through the entire backbone. But then your backprop just needs to be local to whatever that diffusion block actually is. Does that make sense? It kind of wrinkles my brain, but it basically makes sense. Residual connections is Euler steps of the reverse diffusion process. That's what I drew in the MS Paint, basically. Partition L layers into B blocks, define noise and partition into B intervals, and then augment each block with noise conditioning. See, so you actually do literally add the noise. So it's diffusion blocks because we're not just like pretending it's diffusion. We're actually adding a noise and trying to predict it as like a denoising task. This is prettier than what I remember reviewing. Not that what I reviewed wasn't good enough, but I mean, I voted accept, so obviously it was. I'm trying to get down to the results now. And Hassan, feel free to put your questions that you have about it when you have them. I feel like I covered it at the high level. That's like good enough for most people, but maybe you have a more specific question. So yeah, we can look at the numbers here. They do like some basic LLM stuff based on like perplexity. And in this case, like for this data set, they generally improve the result. For this data set, they're more trying to argue that they maintain the result. And I believe it's 4 times memory reduction because in this particular implementation, they use b equals 4 probably, but I'm not sure. And I don't think I care about that specific detail. Text generation, they're able to improve results in a lot of cases. Let's look at so classification is what prior works had done. So they do have a classification result somewhere around here. Here it is. This was a big concern of a lot of reviewers. I'm trying to remember how they addressed it, but basically the prior work was getting like, better than random, but terrible. And they get pretty close to the VIT result on CIFAR 100. I think a lot of us were nervous about it not scaling. I can't remember. I mean, for the DIT, they did ImageNet. So this was, I think this may have been the result they came back with in the rebuttal that was pretty encouraging. That's like decent scale. And the FIDs are comparable. I remember some people were frustrated it didn't like literally match the paper FID, and that is a little scary. It's like you don't need a ton of compute to get down to a setting with around 3 FID, whereas they insisted on doing something with 9 FID. But it's hard because it's like you don't know whose paper you're reviewing and how much compute they have access to. So it's definitely something where like I remain skeptical that it's actually ever going to be practical, but it is interesting, I think, and it's promising, right? Like this goes, especially the ImageNet DIT, it goes a little beyond what I considered purely a toy experiment and into something that is like some reasonable proof of concept. And it's like part of it for me too is that like the experiments seem thorough. Can I predict the scaling? No. But like if it scales, the impact is massive. And so it's like I don't really want to gatekeep the first instantiation of it just because they didn't have access to more data or more GPUs or something. Right. Do we skip time steps similar to DDIM using non-Markovian math or ODE solvers? That's a great question, son. My understanding is we skip like even more steps. It's like I don't think we'll look for the exact detail, but my understanding is that like they make it seem almost continuous here, but really like if I have 3 blocks, like this one does noise 100, this one does noise 667, this one does noise 333. That's my understanding. Oh, we have a range maybe. Okay, the blocks have a noise range. Sorry. So it's not quite. It's roughly like that though. Like, can we find any specific examples? So it's within a range. So it's like this one would be like 1,000 to like 800 or something, and this one would be like 800 to like something else. But it's not like you loop it. My understanding is you don't have to loop within the block to finish denoising it, because that would just make the forward way more expensive. I don't believe that's what's happening here. I think you just don't have a fixed noise level so that it doesn't get totally like degenerate. But actually, you're making me want to try to remember. And keep in mind, I reviewed this a relatively long time ago. I reviewed it dozens and dozens or hundreds of papers ago. So forgive me for not remembering maybe every detail. Uh, let's see. Oh, we can look at the inference right here. Okay, so input is X. For layers, do output of the last layer plus processing the current layer, basically. So yeah, the inference is just going through all the blocks. No, that's standard network. That's standard network. I'm so dumb. Okay, sample noise. For every I to T minus B, do select block B, and sample the sigma relative to B, process with the given block in the network, and okay, so it does slow down inference then. By how much? Sorry, this is what I get for just trying to remember instead of looking, and it's been a while since I was reviewing this paper. What is I'm trying to remember the solver that they use specifically. Well, we can just look at the solver. There we go. There we go. We can go look at the steps too. They'll say that somewhere. I'm trying to remember. I feel like it wasn't a lot from my recollection. And let me see. So this is a confusing thing too, is like sometimes I feel like they changed it based on the task. Let's see. Let's try to find some concrete number of steps because that should make it clear. Oh my goodness, we just like glazed right over that, didn't we? Nope, that's related works. Okay, 12 layer VIT, partition into B equals 3 blocks, but what is the, what's the number of steps? I'm trying to remember the number of steps where you find it in the paper. You're reliving my experience reviewing this paper in real time, I think, which is like thinking I understood it, then realizing I didn't, and then iterating on that a few times until I did. Where is the number of steps? It's possible I bamboozled myself again, and the first thing I said was right. And I just convinced myself that it wasn't right because it started looking not right. Yeah, let's go back to it and look very closely at the symbols just to see. Um, oh, they're going to tell us a bit about how they pick the time step range. Okay, a naive approach would divide the range uniformly. However, that was a bad misclick. Bad misclick. A naive approach would divide the time steps uniformly. Yeah, that's kind of what I imagined. However, this fails to account for the varying difficulty of noising. So they have a log normal distribution for sampling noise levels during training. Okay. And this distribution constitutes probability mass at the intermediate noise levels, which empirically contribute most to generation quality. So to preserve this distribution across the whole network, they partition based on cumulative probability mass. Okay, so like the first block is going to go further into the intermediate steps than you would expect. So that every block handles equal parts of the probability mass. But, implementation details. To smooth transition across block boundaries, we slightly extend the intervals in the space. Okay, and according to some gamma, weighting and preconditioning, that's not what we want. We want the number of steps. Blocks are randomly sampled per iteration. Nope. Blocks can be alternatively trained in parallel. Nope. During inference, we generate samples by sequentially applying blocks from. Nope. While I use Euler steps in our experiments due to natural correspondence between residual connections and Euler discretization, our framework is not limited to this choice. Yeah, but how many Euler steps? Guys, how many of them? How many steps? I can't. I knew this at one point in time. I wish I still knew it now. How do they handle discontinuities in the diffusion trajectory during inference? Training block wise? I think we just saw that, right, Raj? They overlap it a little bit. In terms of training, they overlap it a little bit. But then in terms of inference, you can just use the ones that are responsible for each. I'm trying to see, though, how many steps it actually is, because I'm trying to remember. I feel like we talked about the runtime a bit in the reviews, and I just cannot remember what the answers were. Can't remember. Was someone, maybe it was even me, asked about activation checkpointing. Reduces only activation memory, but they reduce all memory components by a factor of B. That's the advantage compared to gradient checkpointing. Inference efficiency, there we go. For inference, we ensure that the 12-mount computation matches that of the baseline model. For a 12-layer network, the baseline performs a single forward pass through all 12 layers. Under diffusion blocks with B equals 3, we perform 3 denoising steps. Okay, so I bamboozled myself. Because hypothetically, you could do more steps, but they actually do 3 steps. Make sense? Wait. But yeah, for the diffusion, that it's different, but this is the inference. So what I said at first was right. At inference, first thing I said was right, thank God. At inference, it's like 1,667, 333. Or if you want to define in terms of Euler, it's like on a 3-step schedule, 1, 2, 3, I guess. Cool. So that's diffusion blocks. Anything else, Hassan? So it's Euler solver. And yeah, we're skipping hello steps. Oh, Sam said, what's the target of each loss? Of each block in the loss? Here, I'll show you the loss. By the network modification recipe, we transform the original phi4 map to a recursive denoising map in a diffusion process. The advantage of this modification is the fact that the objective equation 2 can be optimized at any noise level independently of knowledge of other noise levels. This allows us to define a training objective for each block B. That is the most important question, Sams, and I am somehow struggling to recall it. I promise at the time I reviewed the paper, I knew it. I promise. Each block and yeah. Collectively, yeah. Here we go. Does this make sense? Diffusion blocks. Oh right, it's all they're all independent. Like they're all independently trying to get the objective from their little slice of heaven. Does that make sense, Sam's? The target of each block is the same as the target of the original network. But like diffusion wise, right? So we have like for the VIT we have the real label, we have the noise, and we try to predict like the velocity to recover the actual label on the CLS token. For diffusion, I think it's more obvious. It's like every tiny part of the network is responsible for, like, for diffusion, it's kind of weird because you end up with 2 time steps. You have like the time step and the time step, but it's like, yeah, you have 2 kinds of time steps. That's really funky. I hope that makes sense. Ask me a more specific. I think it makes sense in my head. I don't know if I'm explaining it super well, Sam's. if you don't understand it also from looking at this, maybe with a more specific question, I can give like a good answer that puts, I think, the intuition I have in my head like into like better words. Okay. So Raj says, nope, answered Raj. Raj says, will increase generation cost? No, because as they mentioned, they do like each block at inference, one denoising step. So they don't like loop the blocks or something when they're actually doing the inference. Except for in diffusion, like when it's being a diffusion model, but then you're like looping the whole thing at once. You're not like looping block and then looping block. That would be kind of neat, but that's not what they seem to do. I did wonder, but I don't remember if I bothered them enough to ask them, can I improve performance by looping within the block? Like heavier inference, test time scaling, basically? I wish I asked. I don't think I did. Okay. Grace says, hi, Matt. I hope you're doing well. I have some questions about getting research roles, but I assume those are better suited for your asking me about AI research stream. You can ask me anything in any stream and I'll kind of answer. I think we're just winding down this paper. I'm going to sit on it a little bit more in case Raj or Sam's or Hassan had other questions that I didn't answer super well. Your question is a question I answer quite a bit. I think Hassan pointed out when someone else was asking that like my videos, like my long interview video with Ani is pretty decent. What else is good? Oh, Sam's had a paper rec request. Dang, I missed that. I'm so bad at chat. Okay, do you want PhD? Master's versus PhD. So you got rejected from grad school. Those are all three, I think, really good videos for your type of question. Let me pull up my YouTube and see if I recommend any of my other own videos. But first, let me put Sam's paper request in here. Why did I type paper rec? Oh, I think I saw this. Yeah, because it's Furong's paper. Yeah, I saw this. Yeah, we can look at that. Okay, and I'm also going to go into my YouTube and see if I have any other videos that I feel like answer that question, and then I'll give like a really short answer. But I think I have even more videos that I feel answer that pretty well. The secret to picking a great PhD advisor covers it a little bit. Why is my advisor ignoring me? Gives some like reasonable advice. How to ask for better letters of recommendation is also kind of about talking to like faculty and stuff. But anyway, more specific answer. Oh, you didn't really ask the question. You have some questions. Feel free to type them, and I'll give like little answers here and there. Yeah, just type them up. Type them up, and I will answer. Okay, soundness bench. Can your AI scientists really tell good research ideas from bad ones? I am interested to know. What is the answer to this? Can it? Can it tell? I would love it if it could. Okay, I'm not actually leaving everybody. This is just what I had up before. Okay, so existing benchmarks rarely test a fundamental bottleneck. Can the LLM judge the methodological viability of an idea before expending time and resources? They design a benchmark with 1,000 proposals from iClear submissions, labeled with the reviewer soundness subscores, and audited against source papers. Okay. So can I teach an LLM to correlate with... So wait, do they treat the papers as proposals? Oh no, they reconstruct the proposals from the submissions and then look at the actual soundness after the fact. That's iffy because I feel like a lot of what messes with soundness is just someone's failure to execute on their idea. Like, I feel like there would have been better metrics to couple this to in an iClear review to get it to make sense. But anyway, can we get the agent to correlate? Well, maybe. I don't really care about the statistics. Just can the agent correlate? Yeah, right? We want to see a high, be high. Right, this is good. We want most of our density in high. Do we also want a lot of density in low? Right, yes, we do. We want density in low, and high. Basically, a lot of density in high-low just says, like, the model really loves you, and it'll say everything is good. So I think a lot of these are already better than random, at least when it comes to, like, an iClear soundness score. Which, there's a lot of confounders, right? Because, like, the iClear soundness score could be biased to really have nothing to do with whether the idea is actually sound, but just whether, like, it sounds sound. Huh. This is... I don't know. I've covered as much as I want to. You got questions about it, Sam? Sorry to get to it so freaking slow. Yeah, I'll definitely rewatch those, but my position is graduating from a BS, CS, and MSCS at a university that doesn't do any research. Okay, no research, and you're already having a master's that you're getting. Oh, going into master's. Okay, you're going into master's at a place with no research. That sounds not like something I'd recommend at all if you're a person that wants to do research. You're basically taking your last opportunity to get into research with no research experience and not doing that. Um, I don't think I'm going to necessarily convince you to drop out of your master's 2 months or 3 months before you start it. But that's immediately a red flag, right? Because like a lot of what a master's can be to people that can afford it is a chance to take their no research resume but good GPA and go to some decent program that has research faculty to work with them in their lab for 1 year or 2 years during the master's and hopefully get enough background to then do a PhD. So what can you do without that? I mean, it's a lot iffier, right? So yeah, if your university doesn't do any research, getting research roles looks like somehow getting internships uh during the year during the summer, right? So finding places or groups like you're probably going to struggle if you have no experience with getting internship with anyone that's like we want to write a paper, but maybe you can at least find internships that are like a little more product researchy and you can kind of get closer to it that way. That's how I would frame it for you though. It's like you want to take little steps to get closer to research. And so when you're looking at your industry internships, you're looking for things that are closer to research. Or if your program doesn't have research but offers a capstone, you're looking to do something kind of researchy there. If you're looking for like specific not easy, but like well constrained problems for capstone type of work, what you want to look at are major conferences like CVPR and NeurIPS. You want to look at their workshops and more specifically the challenge tracks at those workshops. Challenge tracks will give you data and a problem statement, and you just have to try to solve it the best that you can. That's a great way to try to get into research. Or like places like Comma AI. Um, Sometimes not them, but like any one. Where is it? Comma AI compression leaderboard. Yeah, challenges that they face, they'll just throw up here, and anyone can look at them and solve them. And they're hiring. If you do really well, they might want to hire you. They're not the only people that have ever done like research bounties. Research bounties are a thing, so you can try to look into research bounties or Kaggle or stuff like that. Ways to kind of cut your teeth on not maybe super bleeding edge stuff, but actually pushing like engineering state of the art in ways where you have to do research in order to get the best result. I have 4 TA roles and 2 research roles, but the classical AI and HCI and only the HCI one is potentially targeting a paper human subject study. Okay, you said a university that doesn't do any research. So now I'm confused. Your BSCS school does research, your MSCS school doesn't. HCI research is still good. I mean, pivoting from HCI research to ML research should be easier than it is, but like ML people really want to see you having done ML research. It depends. I think I don't know enough about what you want to answer your question though, because having an HCI paper sounds pretty good unless you're saying you really want to do AI research, which I don't think you specified that very clearly on what you said so far. Same school, and sorry, I meant that nobody publishes AI ML, much less. Oh, AI safety is your interest. I think in HCI you're in a decentish spot then for like a lot of AI safety research overlaps HCI a lot. And I've seen HCI people sort of pivot into safety adjacent things. I think the easiest way to explore that is with your faculty supervisor that's doing HCI. Just you'll need to learn on your own the gist of some flavors of AI safety literature and then propose and work on some project with them that's AI safety. There's plenty of AI safety stuff though that's basically HCI. I'm not an expert in it, so nothing is coming to me like off the dome. But I feel like I see a lot of those where I don't know, like it'd be kind of interesting when it comes to AI safety to see some like 10-person snowball sampling interview type of study of like real people's experience with like some LLM, right? Or you'd be studying like LLM psychosis, which is an HCI question, not really like a theoretical AI question. So yeah, if AI safety is your interest, I think you could probably, as long as you can bring some of the AI safety specific stuff to the table, find HCI faculty that might be willing to or interested in working on that problem with you. or if like you're working on safety, analyzing like safety, safety meaning like security safety. Like if you're working on security in HCI, um, an AI safety thing there would be like, how does OpenClaw compromise the fact that I want my money to stay in my own wallet as opposed to going other places, if I get access there. I don't know, like what kind of new vulnerabilities are there in people's daily lives because of their use of and reliance on LLMs? Stuff like that feels more like the HCI side of AI safety rather than like the AI theory side of AI safety, which I don't even know if I believe there is a theory side of AI safety. You can view the tech overview on their website to view their approach. Oh, are you talking about diffusion blocks still, Sims? Or are you talking about soundness bench? You're talking about this? Or are we talking about... We're not talking about this, right? What are you talking about, Hassan? You talking about this? You got filtered? What? What do you mean, Hassan? Oh, like you posted a link and YouTube Automod like didn't let you post a link, right? You just need to type the title. I wonder how many people that happens to silently because I don't even see it when that happens. Paperreview.ai. What about it, Hassan? You're just talking about the fact that you can like do pre-review with their agent to get suggestions for your work? Or are you asking for my opinion about it? What you want to know about this, Hassan? Okay, we can look at the workflow. Let's see. Tech overview. The inspiration for this project was a conversation one of us had with a student. The research paper was rejected a lot of times. Wow, that's a long time to try to keep a paper alive. When modified to output a 1 to 10 score, we found that Spearman correlation between one human review and another is 0.41. That's crazy. Whereas the correlation between AI and one human reviewer is 0.42, which suggests that the agentic... I don't know how much I like this conclusion. If I thought about it for a minute, there's definitely some category error here. The agentic system takes the paper PDF and optional target venue as input. To ground the paper review in the latest prior work, the agent analyzes the paper to generate web search queries at different levels of specificity, which are executed to find relevant papers in archive, downloads the metadata, balance coverage, and blah, 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 blah. Looks up lots of papers, and then scores the paper on 7 subdimensions, tries to make a score, give you some feedback. That's neat. The line about agentic review approaching human level perf is biased. Spearman correlation of the best metrics is misrepresented, I think. Yeah, that's a better way to say what I'm trying to say. I mean, it also like, sure. I mean, I actually kind of buy that maybe AI reviewers are kind of as good as human reviewers, but only in the sense that human reviewers are, on average, pretty bad a lot of the time. And so it's like, what I would kind of buy is that like the AI review can kind of be like the average human review, but it's like the only thing that keeps me going is the fact that some human reviewers are good, whereas I don't know. I'm a fan of like AI review to give you feedback on your own thing, I guess. Sometimes it depends on what kind of feedback you want, but the idea that we want to put them into the review loop is kind of scary because it basically takes the current problems we have where we think our review system is totally broken and canonicalizes that. And that's not a good idea. Isn't Soundness Bench trying to do the same thing as this website is doing? Yes, I think so, Hassan. I think it's the exact same thing. Okay, it's a similar thing. Little difference. Soundness Bench takes the paper, converts it to a proposal, and tries to evaluate the proposal, like basically project the future of that proposal. So the model doesn't look at the paper. It looks at a proposal that would, if it worked out, turn into that paper. Whereas this is trying to look at papers and grade papers. So one of them is trying to grade ideas, where the supervision is looking at iClear, did that work? And the other one is trying to grade the paper itself. Does that make sense? It's technically different, although the methodology ends up being like, you basically crawl the data set the same way. It ends up being really similar. Interactive world model evaluation. What? Oh, it's from Longcat. I was like, this isn't Longcat paper. It's from the Longcat team, though. Okay. So we have lots of different world settings, styles, subjects, perspectives, many different, well, not many different interactions. We can move ourselves or the camera. Well, we can basically move ourselves and look around. We can manipulate. We can do some editing stuff, like to the environment, and we can switch perspective. I don't know what this is trying to talk about. Like I can give what? Including the world settings, interaction taxonomy, unified navigation. Oh, is this just saying like, this is just saying that any of the crap that I do here gets translated into whatever it needs to be, I guess. Okay, comprehensive evaluation. We evaluate in terms of consistency, semantic interaction, navigation interaction, setting adherence, video quality, physical, and we evaluate all these different open whatevers. Open? Are these all? No, these aren't all open. This one's open, I think. This one's not. Okay. So we're evaluating some closed source stuff. Do I understand how this benchmark works yet? No, not at all. I understand what they're evaluating, but not how it works. Is this just going to be VLM based? Do a thing, then ask the VLM, did it happen right? Probably. Can we find a diagram that explains how it works? Video quality measures the perceptual quality of the generated video. 5 submetrics from VBench: aesthetic quality, imaging quality, temporal flickering, dynamic degree of motion smoothness. I don't like VBench very much. It's super saturated. Not a good benchmark to use for modern models at all. Setting adherence, scene adherence. Decompose the environment prompt into initially visible part and an off-screen part expected to appear later. VLM scores it. VLM scores it. Interaction adherence. VLM scoring. Consistency. Megasam. Estimate camera poses and then compute dream sim perceptual similarity within the first frame. Transnet V2 to delete. Use a scene cut to detect unexpected hard cuts. It's like if the scene cut says it's a new scene, then we say it like accidentally scene cut. That's really funny. Perspective consistency. We track the subject of SIM2 and measure how stable its centroid remains across frames. Weighted by the fraction of frames in which the subject is interesting. Okay, so it's a combination of things. There's some SAM, there's some depth anything, there's some like scene cut to do random stuff, there's some VLM. I like the overall gist of it and the careful attention that they put into the construction. I clicked this though because I think it says multi-turn and I read it as multi-agent. But also I just need to know what the benchmarks are for world model stuff. And now I know. Cool. How is the scope for AI hardware jobs? Is it a good time to go for hardware PhDs? I have no clue, Raj. That's a great question. Embedded system control signal, I really don't know. I know it's a good time to be like an HPC person, high performance computing, or like to do some of those things. But I don't know if it's a better time to be that person than to just be like the actual AI ML person. I don't know about the hardware market though. Like that's not something I have any visibility into. I don't see it anywhere, I guess. I was looking at a fall internship at Center for AI Safety, and there was a junior my age who got one of the positions who's already published like 6 papers at ICML/NeurIPS. How do I approach that? That's a great question, Gray. I think one way you approach that is you're not going to be that person, and that's okay. I think I come across a lot of those people on my side of AI too. My side of AI as well. Like people that just have a ton of papers, and it's like, oh my God, how do they do that? All you can do is focus on yourself and improving yourself and trying to do interesting work and hoping that that interesting work takes you to interesting places. Um, some people have a lot of advantages in terms of what they knew before they wanted to do this. That's part of why I made the channel, to try to kind of level the playing field to some extent, or at least to give anyone that wants to watch a leg up on other people. But it's hard. I would focus more on your own work and the feedback that you get when you apply to such places. And looking at what credentials it tends to take to get things that you want can be good for just being realistic about your options. But do be careful, because occasionally you'll find people that iterate on the paper metric and people sort of see right through it. Also, like, having a couple of second authors as an undergrad is fine. When you, if it's 6 second author papers, which I don't know because I'm not looking at their profile, so who knows. That's not looked at too much differently than if there were just 1 or 2 of them, because it's like, okay, you need to do your own proper like first author work. But again, maybe this is a person with 6 first author papers, who knows. So yeah, I would guess that the Center for AI Safety probably hires people that don't have, you know, such insane resume also sometimes, or some AI safety jobs definitely do. And so I'd say just focus on working on yourself. Try to pay attention to what seems to be the average resume that gets into any given place, but also don't get too discouraged about, you know, the random outliers that you'll see rocket through the ranks of different places. Random questions. I've heard that researchers are bad at programming / maintaining code or something like that. Your thoughts and experience? Um, Most of us are bad compared to engineers, yeah. Because engineers do that and we do research. So they're like 2 different things. I suppose that some researchers might be good engineers, but that's not the experience I've had using other people's research code for like 9 years or whatever. But that's okay. Like, to some extent, trying to really engineer something well can be an impediment to just getting the implementation done that you need to, like, learn things from. And like a lot of great engineering supports scaling, going from 1 to 100 or 100 to 100 million. We mostly need to go 0 to 1. That being said, when you start working on production, you need to write code that is itself fast. It just still doesn't necessarily need to be like super well designed or organized sometimes. And then the AI of it all really throws a wrench in it, because it's like probably your average researcher shouldn't write any code ever anymore. So that changes things a little bit too. It's like now I'm even worse at code, you could argue, because my agent writes it all and my agent writes too much code. So that's just even harder to read and understand my code. Yeah, and I think a lot of researchers probably just don't like maintaining code. Or who likes maintaining code? I don't know. It's not very fun to just keep something maintained or whatever. Okay. Pipeline aware and expert calibrated benchmarking for professional cinematic video generation. This is probably not going to be very interesting, so let's look quickly. Evalverse digitizes subjective cinematic expertise into computable expert calibrated evaluation frameworks with 5 steps to establishing a taxonomy, curating a dataset, bridging the historical divide between human aesthetic perception and algorithmic scoring by synergizing specialized perception extractors with expert guided chain of thought process. Align the VLM with 34 professional experts. Okay, so they actually get a bunch of people to like write reasons that something's good, and then they try to align the machine to that. Do they open source any of it? That would be kind of neat. I don't see it yet. Okay, I don't really care then. That, yeah. Huh. Huh. From pixels to words. Any opinion? So Flueep, Flueep, Flu, Eep, Flu, Eprian. Okay, I'm gonna stop trying. I don't know where the first name starts and the last name begins. Any opinion on CMU's 30 master degrees and if they might be worth it in the AI era for software engineer / MLE job security? Personal experience would be highly valuable. I can name a few CMU masters off the top of my head. Let's see. 30 is 30 master's degrees exaggerating, because I can think of 3. But like those just might be the three. Okay, let's see. Is this what we're talking? Like if I search, I mean, there's way more than see. This is what there's more than 30 of these. But like what? Let's define our terms here. What are we talking about? Um, right. What are we talking about? Okay, so you might be including these because they're under ECE, right? MS in software engineering, MS in software engineering, MS in ECE, MS in ECE, MS in AI engineering. Okay, so there's those. There's also there's an Africa campus. I did not know that. Let's see. I'm looking for the ones that I know. Where are the ones that I what? Oh, okay. It's with the okay. So I know of this one. I don't know if it's different from this one. I know of this one. I know of this one. I don't know about this one. This is the best one, to my knowledge. Um, these are fine. I don't know about anything else. Personal experience. I have someone I mentored during my PhD, and he is at this, and he's doing pretty well. My advisor, uh, started with MSR at CMU, and he's doing pretty well. So I tend to have a favorable opinion of the MSR, but in his MS, I believe it was during his MS that he started working with Alyosha, when Alyosha was still at CMU, and then after he works with Abhinav Gupta because Alyosha went to Berkeley. But um, so like it's important to work with faculty while you're doing that MS if you want it to be like a really productive MS. I don't know if just getting an MS gives you job security. It makes you more expensive to hire probably, and that doesn't always give you job security. So that's really hard. You're asking me to comment on something that's really hard for me to comment on, just because it pushes like the envelope on what I know. So like I guess I've told you the three that I know something about, and it's that this is the best one, and then these are probably okay. Um, yeah, no, 30 sounds probably just underneath. We're under School of Computer Science. One, two, three, four. This is probably 30 here. Yeah, those are the ones I have an opinion about. Don't have an opinion on the others, but I mean, Carnegie Mellon has so many excellent programs that a lot of these MSs that are just like these plain MSs are probably all pretty good. Um, if you can manage to work with like faculty and do research during that time. Otherwise, they're probably like okay, is my guess. Yeah, MSCV I think is decent. Like I think if I'm just being frank, I think you would have preferred MSR, but like I think MSCV a lot of the courses can overlap. It's just considered maybe slightly less prestigious, is my vague understanding without being too close to it. Um, but still, I think when my mentee he got these acceptances first, and I think we were still thinking he should take one of them even before he got this. That's my recollection. Take that over, I think, PhD at UMD was the idea. I think, or I think we were thinking they could be very close, potentially. Granted, that's assuming you put in the work. Like if you just show up, do your courses, go home, you're not really getting the full value out of this, right? You need to try to find the research opportunities when you're there. But yeah, that's my vague impression based on having thought about it for the last time, like over a little over a year ago. So I hope my information is not too out of date. The funding environment's always changing, and that affects master students before it affects PhD students. So that's something to keep in mind. Um, so I hope I didn't calm you only to uncalm you, but I just don't want to also provide like any false impression, right? Like my impressions of things are very frozen in time. Oh, Raj retracted a message. I hope that wasn't a paper request, Raj. If it is, maybe you can try typing it again. I answered Hudson's question. I got Raj. Um, I answered Fluip Rian's question. Oh, by the way, if anyone's here that is interested, if you want to know when I'm going live in the future, it's every Sunday at 9 a.m., but also we have a Discord. So you can join my Discord, and I ping going live when I'm going live. That's the idea. So I'll ping it every Sunday at 9 a.m. I also might ping it during the week if I have time to go live during the week. I think we'll be winding down the stream here in just a minute. Does anybody have any last minute requests for papers? I know I opened a lot here. I typically bite off way more than I can chew in these streams. But it's time for me to hop off and go hang out with my kids for a while. Clean latent prediction and latent diffusion transformers. I think that these people just got hilariously scooped by JIT, right? Oh no, they're saying okay. They're like JIT prove you can do it with images. We're wondering if you can do it with the latents. Okay, I'm closing that. Cool, good for them. Um, it's nice to do little like exploration things like that, and now we know. Okay, that's a thing. Well, except I would be shocked if you couldn't do that. That would be crazy. We already know that you can do. I feel like I don't know. Whatever. Native audio-visual alignment for generation. I wanted to see what this is talking about. Is it like some kind of rope, or is it some kind of like what are they doing? Comparisons to different audiovisual generation paradigms, dual towers, separate audio and video feature spaces with late-stage cross-modal alignment, fully unified, single trimodal space that couples context conditioning and synchronization. They have dedicated audio-video alignment followed by external context conditioning for controllable generation. Okay, so they have a fully unified space, and then they can guide that with context to like have like clusters, I guess, within that space that make the generation more controllable. Um, and then their MMDIT is going to be dual stage, right? And then or dual stream and then single stream? Or this kind of just looks like single stream. No. It's like you can do what? Yeah, I think this is trying to show a dual stream. And this is trying to show a single stream. Yeah. So kind of like the older Flux idea, right? Okay, that's fine. Um, see you next Sunday. See you, Hassan. Raj has one more request. I might hit it super quick and then just seeing if I can burn down the rest of this list I opened up. Get the rough impression of what's happening out there in the world. Discrete flow maps. Oh, discrete flow maps. That sounds cool. The sequential nature of autoregressive, blah, 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 impose a fundamental speed limit. While continuous flow models often have path to parallel generation, they traditionally demand expensive iterative integration. Flow maps bypasses the bottleneck by compressing generative trajectories into single-step mappings, theoretically enabling the generation of full text sequences from noise in a single forward pass. Okay, so it's single-step denoising. Standard formulations are only Euclidean regression losses that are geometrically suited for discrete data. In this work, we resolve this conflict with discrete flow maps, a framework that reconciles trajectory compression with the geometry of probability of the probability simplex. We recast standard flow map training for the discrete domain. So it's discrete and it's one step, right? Or it can be one step. They can do 8-step, they can do one step, without like horrendous perplexity. So they can do one step. Not parallel generation though. It's still autoregressive, I believe. It's autoregressive, but like single step, not multiple denoising steps. No. It's a diffusion model. It would be. This is where I get screwed up with diffusion language models. Maybe they have a nice table where they're going to show me the inference time. I like simplexes, by the way. Simplexes are my understanding of how like knowledge distillation works back when it was just for classification. Where it's like our soft target is like basically our one hot targets are just these points on the simplex. And then our soft targets are like the model's prediction basically is just somewhere else on that simplex, somewhere in between them. It's like it's cat-like, but a little fox-like, a little dog-like. Simplexes are very intuitively satisfying to me. Okay, so illustration of block generation with mixed attention masking. A fixed context green is processed with causal attention, while block of future tokens red is generated in parallel. Bidirectional attention. Okay, cool. So we have the context, which we process the causal attention, and then we generate an entire block all at once with as few as a single step, which we can do because because like what is the I don't know. My brain is kind of tired to be going through something this heavy right now. I mean, it's nice to know it can be done. compress the generator trajectories into single step mappings. Like it's whole block, single step, discrete. I know those are possible. Maybe later I'll come back and look more at how. Also, I'm curious if we see like speed ups anywhere. I don't just care about NFEs because like different models have different cost per function evaluation, right? Is theirs a lot better than these prior works, I guess? Like um yeah, like way better, way better, way better. I have a friend who does DLMs. Maybe I should talk to them about this. I'm curious to understand it better. But not only do I have to understand all this math real quick, I would also have to understand diffusion language models better than I do, which I just don't. And I'm not at the point in the stream where I want to. Is this kind of like, isn't this kind of like diffusion LLMs? No, this is a diffusion LLM. Um, did Stefano really do the first diffusion LLM? I don't think so. I mean, this is not saying it's proposing the diffusion LLM, or is it kind of? Oh, sorry, I read it from the beginning as just like an iteration on diffusion LLMs, but they're not actually using that term anywhere, are they? No, they're really not. Weird. Weird. Yeah, Hassan, I would say this is like diffusion LLMs. I might say it's, yeah, inspired by Stefano's work or by like the stuff that Shubham works on. Um, yeah, I'm gonna ask Shubham about this paper. It's kind of older now, so I assume he's seen it. Because it makes me wonder, like, part of the difficulty of doing integrated image text stuff is text likes discrete, image likes continuous. Does this kind of point to, like, I guess text is already fine with the discrete, but like, if I can make the discrete map continue, if I can make the flow discrete instead of continuous, can I make the image happy with that? But I still have like the codebook sampling problem, so I don't know. Okay, there we go. I looked at that for a minute, Raj. I think I'm just about out of gas then. Thanks everyone for watching. It's been fun. Look forward to seeing you next week, hopefully during the week. But it depends. I'm going to CVPR. If the hotel Wi-Fi is good, maybe I stream one night when I'm there. If I have nothing better to do, maybe not. Otherwise, until next Sunday. Bye. Bye everybody. Catch you later.